Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will go through limiting geometric series. So that occurs when you have a geometric series and r is between but not including -1 and 1. If r is between -1 and 1, you can add infinitely many terms according to this formula. So let's look at this example to see what's going on. We're adding 1 plus a third plus 1/9, etc. These dots mean it goes forever. So we're actually adding here infinitely many numbers. So a lot of people would think, okay, well, that's got to be infinity. You add infinitely many things, your answer's going to be infinite. But what's happening here is if r is between -1 and 1, each subsequent term is getting closer and closer to 0. So these subsequent terms, they will eventually get so small, they really don't add much to the sum. So that's why, even if we add infinitely many of these terms, we'll get a finite answer. So this sum is just simply a over 1 minus r. If you've forgotten how to calculate r, take any term and divide the previous term. Any term, divide the previous term. R here is a third because we're multiplying each term by a third to get the next term. So if you put that on your calculator, we actually just get a half. So if you add up these terms, it will get closer and closer to a half. So it's like 1, 1.3 recurring, 1.4 recurring, and so on. It will get closer and closer to, but never exactly reach a half. So half is the limiting sum. It is the limit of this sum. It will never go past a half, no matter how many terms you add up. So let's look at how we can apply this to converting recurring decimals to fractions. So we're going to look at converting 0.2 recurring to a fraction. See, 0.2 recurring is 0.22222. It goes on forever. Now, what we know about place value is this column is tenths, then hundredths, thousandths, and so on. This is just 2 over 10 plus 2 in the hundredths column plus 2 in the thousandths column, and so on. This here is a geometric series. Now, here we clearly have r is equal to 1/10. For each term, we times by 1/10 to get the next term. So this will reach a limit. If you keep adding terms over and over again, it will reach a limit. So that limit is going to be given by a, the first term, over 1 minus r, which we decided was 1 over 10. You can put it straight in your calculator, you get 2/9. 0.2 recurring is equal to 2 over 9. So what about this example here, 0.13 recurring? Well, this is 0.131313. It goes on forever. So here we have a 1 in the tenths column, we have a 3 in the hundredths column, we have a 1 in the thousandths column, and so on. Now, hopefully here you're starting to think, oh dear, have we run into a problem? And we have run into a problem because what I've listed here in blue is not a geometric series. We're not timesing by the same thing each time. However, we can decompose this into 2 geometric series. If I put all the ones together, there's a 1 in the tenths column, a 1 in the thousandths column, and you can probably guess the next one will be in the 100,000ths column. This here in green is a geometric series. Similarly, if I put all the 3's together, 3 over 100 plus 3 over 10,000, and so on, it is also a geometric series. So what I'm going to do is calculate first bracket and second bracket. Now this has a limit. There are infinitely many terms, and r is equal to 1 over 100. So the sum of this first bracket will just be a over 1 minus r. Similarly, there is a limit for this second bracket as well. R is 1 over 100. So the limit will be first term divided by 1 minus r. R is again 1 over 100. If you need to check that, take any term, divide the previous term. Any term, divide the previous term. So the first fraction here, if you put it on your calculator, you get 10 over 99, and the second gives you 3 over 99. So adding those together, we simply get 13 over 99, and we're done. Let's look at some harder questions now. So we're going to calculate x if 1 plus x squared and so on is equal to 2/3. So here, because we're adding infinitely many terms, and because this is a geometric sequence, we can use our formula s infinity equals a over 1 minus r. So notice that in this case, the limiting sum is 2/3. A is clearly 1, that's the first term, but r, the common ratio, is x. X divide 1, x squared divide x cubed divide x squared. This is a geometric series because we're multiplying each term by the same amount, in this case x. So we just get 2 over 3 equals 1 over 1 minus x. So to solve for x, I'm going to cross multiply. I get 2 times 1 minus x, so 2 times 1, 2 times negative x, is equal to 1 times 3. So this equation is very easy to solve. Simply subtract 2 from both sides, divide by -2, you get x equals -1/2. So this is the sequence 1, -1/2, +1/4, -1/8, and so on. All right, let's look now at a super hard question. So we're told second term of a GP is 20, limiting sum is equal to 125, calculate A and R. So hopefully you're thinking we have to find A and R at the same time. We will use simultaneous equations. So we need 2 equations, and we'll get them from the 2 bits of information. So for any GP, geometric progression or geometric series, the second term is always AR. So we have AR is equal to 20. Now, because the limiting sum is 125, we have A over 1 minus R is equal to 125. So I want to get rid of this fraction here and make it easier to work with. I'm going to times each side here by 1 minus R. So I get A equals 125, 1 minus R. So I have 2 equations here with 2 unknowns. Because I have A by itself, I'm actually going to substitute into this equation. So I have A, which is 125, 1 minus R, multiplied by R is equal to 20. So let's go ahead and expand this. 125 times 1 times R is 125R. 125 times -R times R is minus 125R squared. So this here is a quadratic. We need one side equal to 0. So I'm going to subtract this and add this to both sides. I get 0 equals 125R squared minus 125R plus 20. So because the numbers here are quite big, I'm going to use the quadratic formula. So R will be equal to minus B plus or minus the square root of the discriminant. So the discriminant is just 125 squared minus 4 times 125 times 20. It's actually equal to 5625. And then all divided by 2a. We actually get 2 values here if you put it in your calculator. So the 2 possible values here are r equals 0.8 and r equals 0.2. Both of them are possibilities. So now we need to find a. I'm going to again substitute back here. So if r is equal to 0.8, a is just 20 divided by 0.8, which is 25. If r is 0.2, then a is just 20 divided by 0.2, which is 100. So both of these are possible. We could have the sequence 25, 20, 16. That will give you a limiting sum of 125. We could also have the limiting sum that is 100, 20, 4. That will also give you a limiting sum of 125. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.